Welcome back to our short course on the principles of data visualization. In the first part, we studied some key principles in data visualization, and also we discussed the fact that some data sets may have the same or very similar descriptive measures, but have completely different visualizations. In this part, we are going to study the preattentive processing features and also the Gestalt principles. Let us start with the preattentive processing. The idea here is to work with these 4 questions. First one, what types of features are perceived immediately? The second one is, which visual characteristics are discriminatory, in the sense that which visual characteristics allow us to differentiate one image from another? Then, what are the features or elements that can confuse the viewers? And finally, what data or features should be detected in a graph? And the main reason in this last case is because sometimes we want to differentiate one graph from another. For example, I have 2 lines measuring the performance of a certain model to a given input, and I want to plot these 2 lines in the same graph. How am I going to differentiate these lines? We may use, for example, colors, we may use textures, we may use markings. So all these are called preattentive features, and we are going to discuss them in this class. To discuss the preattentive features, I want to make a simple game with you as follows. If we look at these pictures, we can see that they have some features that differentiate one from another. What are these features? The same thing happens with these pictures here at the bottom. So in this game, we are going to have 4 different pictures for each feature, and I want you to look at these pictures and tell me what is the feature that differentiates them. For example, when I look at these ones, I can see that the shape differentiates one picture from another. Here at the bottom, I can see that the width of the line differentiates one from another. So shape is one preattentive feature, and another one is line width. Ready? For each set of pictures that I give you, I will allow you around 3 seconds for you to guess what is the preattentive feature that we are talking about. After that, I'm going to show you the correct answer. Here we have line color, and here we have the size. Ready for the next? Markings and orientation. Ready for the next one? Position and 3D shape. Ready? Length and curvature. This was a bit tricky, right? Because the length, we could have represented the different in length in different ways, but we chose to use a senoid here of different lengths, and then we have the curvature. Ready for the next one? Density and closure, and finally, texture. Now that we have seen the 13 preattentive features that we wanted to discuss, let's make a quick summary of what we've seen. The feature of shape enables us to automatically detect similarities and differences based on the form of the object that we are visualizing. The width allows us to quickly identify variations in thickness within a group of similar objects. The color helps us to encode data, for example, categories, magnitude, hierarchy, emotions, decisions. For example, green for a traffic light means go, yellow means attention, and red means stop. The size facilitates us to also quickly detect difference in items or objects or visual objects. The markings also allows us to differentiate such that we can clearly identify, for example, different lines, different curves for different items or objects. Orientation helps us to extract information from data points, lines, and objects. The position If we have a clear definition of the environment in which a certain object is located, the position is certainly a preattentive feature in the sense that it helps us to differentiate items from one another. 3D gives us the perception of depth and of spatial relationships between items or objects in a visual. The length creates a contrast in terms of the size or the time necessary to do something. Curvature also gives us a sense of bending, of angularity. Density communicates contrast and emphasizing the importance, the relevance, and the presence of something within the visual. The closure is related with the fact that something is either complete or incomplete. When we talk about closure, we understand that something has to fit or should fit within a certain portion of the space. And finally, the texture also allows us to differentiate between different qualities of objects. This is a summary of the 13 preattentive features that we saw previously. Let us now have a look at the Gestalt principles of visual organization. The Gestalt principles were developed in the early 20th century by a group of German psychologists with the goal of studying the perception of visual forms, such that they could provide a set of theories to describe the way people perceive and organize visual information. We can apply the Gestalt principles to plan the use, to choose which visualization tools we are going to use, and to plan how we are going to use them. Here I am going to focus on the principles of continuity, proximity, similarity, closure, symmetry, figure ground or figure field, and common fate. Based on the principle of continuity, we tend to see objects as belonging to something continuous. For example, if we take this curve, even if we remove the line which is behind the dots, we will still see the dots and understand the dots as if they are part of a curve. In the case of this diagram, what we observe is a number of inputs that converge to one common output here. So we have A, B, C, all of them entering something and converging to the single output. In this scatter plot, we can see that all the dots tend to converge to this straight line, which is a regression, a linear regression of these dots. And this gives us this principle, this perception that we have a continuous set of points within this graph here. The principle of closure brings us this idea, this perception that everything is within a given finite set or region or area of the space. In the example of the pie chart, the sum of the contributions of each of these 4 fruits has to total 100% and has to cover the whole pie. In the case of this word cloud, this balloon is used as a template such that we plot all the words or all the tags within the balloon. But even if I remove the balloon from here, I will still have the perception that all the words are within such a balloon. And finally, in this tree map, we have the same principle, the same idea that we had with the pie chart, which is the fact that all fruits have to fill within the tree map. For the principle of proximity, this is the forest fires data set. Some variables of this data set have very similar correlation values. In this case, the more reddish colors imply in higher correlation values. So we can see here that the highly correlated variables are concentrated more in this region of my heat map. In this picture here, what we observe is that the higher the temperature, the smaller the relative humidity. This plot is also about the forest fires data set. And finally, we ordered here the months based on the average burned area. So we can see that after March, we have the month of June, then February, October, April, August, December, July, September, and May. In the principle of similarity, we can observe, for instance, that for the iris data set of Fisher, all iris varieties have the same number of objects in the dataset. And this similarity can be observed by simply looking at the bar chart of the number of objects for each plant species. Here we plot the sepal length versus the petal length, and we could observe these three lines here. I want to take this opportunity to discuss with you the use of different textures. There are some preattentive features that we've just seen as a way to differentiate these lines. And it's important to note that we also use different colors. In principle, I didn't need to use two different preattentive features, color and texture, to differentiate these three lines. I could use only one of them. For example, color or texture. But I decided to use two of them to detach even more the difference between them and also to provoke this discussion here with you. For the principle of symmetry, let's take the case of the iris dataset of Fisher again, and let's observe here when we plot the box plot with the sepal length that these distributions are quite symmetrical. For example, the iris setosa, we can see that the median, which is the second quartile, is approximately in the middle of the box. Here, for the case of the versicolor species, we have the median a bit under the midpoint of the box, and the same happens with the Virginica species. Here I simply plot the bar chart of the petal width here and mirrored it around the 0 point. In this radar chart, what we have is a symmetry around the 0 value here, and the scale, in this case we have 2, 4, 6, 8, is symmetric around the 0 point here. Figure ground is the Gestalt principle that allows us to differentiate between the background and the foreground. For example, here we have the impression that the blue dots are floating on the top of the orange background. And this is called by this principle of figure ground and the colors that were chosen. The same thing can be observed here, but with a smaller contrast, because the gray background doesn't allow us to have such a big contrast as we have when we combine the orange and the blue. And the same thing happens here. We have a contrast between the gray background and the other colors that we use to plot this map. And here we have the scale. This scale represents the number of individuals in each of these countries. As we can observe, we have China and India with over 1 billion individuals, and we have the United States with over 300 million, right? All the other countries have less than these populations. And finally, we have the common fate Gestalt principle, which basically gives us the idea, the feeling that everything converges to the same place. For example, if you look at these 4 curves, we have this perception, this notion that all of them are moving from left to right, and they're sort of converging to the same type of trend. If we look at this graph here, we are plotting it in 2 different instants of time. First, we have the year 1952, and then we have the year 2007. What we can observe when we move this time button here is that all points, and these points are related with the life expectancy of a population, they all move following a similar trend, but they move to a different position in terms of GDP per capita. In this case, what we could observe was that all of these dots had a trend of increase in terms of life expectancy with the passing of time. To summarize, the 7 Gestalt principles that we presented: continuity, closure, proximity, similarity, symmetry, figure ground, and common fate, we observe that objects that are arranged in a smooth, continuous way are more likely to be perceived as a single object, even if their patterns are interrupted. The closure shows us that incomplete objects are perceived as if they were complete. This was illustrated, for example, with the case of the pie chart, of the tree map, and also of the word cloud plotted within the frame or the template of a balloon. The principle of proximity tells us that objects that are close to one another tend to be perceived as a group or as a pattern. Based on the principle of similarity, Objects that share similar characteristics, for example, color or form, they tend to be perceived as a group or pattern. Also, objects that are symmetrical or that have a balanced appearance, they tend to be perceived as a group or a pattern as well. The figure ground principle deals with objects that can be perceived as either belonging to the foreground or to the background of the picture. And finally, common fate deals with objects that move together or change in a similar way, thus being perceived as a single group or pattern. Thank you for watching and see you in our next class.